Welcome to this webinar. My name is Michał, and today's webinar is about the security of web applications. We've got only 1 hour, and it will be hard to fit in this time with such a wide topic, but I'll do my best to cover most aspects. The agenda of this webinar is divided into 4 groups. It's about methods, potential hazards, how to prevent, and post-mortem. As Jagoda said, you can always ask the questions in the QA section. The button is on the bottom of the screen, it should be there. And I'll answer it on the end of each section if there will be any questions. Also, on some slides, there are QR codes that you can scan to read more about the topic. And these QR codes are actually pointing to my website, and there's a direction. That's because I just want to have a measure of how many people scanned it, so I know which topics are more interesting and which are less interesting. Of course, if you don't want to scan this, if you don't want this direction, I send on all the links in the email that you will receive after this presentation. So let's start with the first vulnerability. It's the XSS vulnerability, which stands for the cross-site scripting. What is this thing? It is basically a situation. Maybe, okay, so now it works. There's a situation where your page has any kind of cookie, or maybe some kind of header sent in the response that contains sensitive data about the user. And cookies basically are just data, and they usually can be stolen because when you run a script in your browser, there's basically a thing called a JavaScript it's JavaScript function, but it's called submit. And it's really it's kind of a CSRF, which will be in the next slide. But what this does is that most browsers nowadays have something called autofill. And the hacker or the bad guy can basically create a form that is hidden from your eyes because it has HTML attribute called hidden, so you cannot see it. And at the same time, in the script section, he is using that JavaScript function to submit. So what he's basically doing, as you go to the page, he's creating the form that is pointing in the action HTML attribute. It is pointing to the actual site that you want to attack. And when the browser sees this form, and when the browser knows that this field is supposed to be password, the autofill is basically autofilling that field with your password that is remembered. And it's automatically sent to the hacker because the JavaScript function .submit is being run automatically when you enter the page, and you basically don't even know that this happened. How to prevent from that? Well, there's basically HTML attribute that is used, that you can use to disable the autofill of password on your site. That's the most obvious way. Also, what you can do is turn off on your client side the password saving, so it won't be filled because the browser doesn't know any of the passwords. Okay, and this topic extends into CSRF, which is cross-site request forgery, and this thing is basically extension of that attack, where the attacker doesn't only attach your cookies and your password and but also the, how to say it, because it's like he's taking a browser and pretending that it's like your person that's doing these actions, because that's for the servers, that's like the same thing. Your browser has your local storage and your cookies, so it's like it's like fooling the server. Maybe he's basically going onto this site and sending the forms on your behalf, and then receiving the request, the response with the authorization token or header, and that's how they got your password. How to protect? Like the same thing. Don't save any passwords, because that's like required to do this attack, because the hacker cannot enter your password into this form on the site. Also, another kind of this attack is like when a certain page has a form that isn't secured and like bases on the authentication token that you have on your local storage. So you're basically logged in, so you can see the form. Then it's going to the form. It's usually like email reset, and this form will be available because you're logged onto that website, and he's filling that form with his email, I mean the attacker's email. And what happens is that he really changes your email on that site to his email, so you don't have any more access to that website, and the account is basically his. For this also, you need to like really care about your passwords, and don't go on some weird looking websites, because that's really well, not a good thing to do. And on the application side, what can we do to prevent this kind of attacks? I mean, XSS and CSRF. Well, basically for CSRF, there's a way of prevention that is basically about creating a hidden field in the form that's filled with some kind of generic token generated on the backend that's sent to the front end. And this field basically cannot be filled by the attacker because it's generated by the backend, so it like won't be possible to attack this from the outside of the web page. So you'll have to go to this actually web page and insert the data by yourself, and this cannot be done by someone else. And that's basically how you are secure with the CSRF and XSS most of the times. Okay, that was the first example. It was more like user perspective. Now let's go to the development perspective. There's a QR code if you want to read more. So on the application perspective, usually in the application you have some kind of authentication, like to identify a user and log him in so he has access to the website. And most people use JWT, which is JSON Web Token, for that. And when you see this, and you just think, well, it looks encrypted, it's complicated, and there's no chance someone will like guess it because it's too long, and it also has 3 sections. And when I like put it into some kind of someone else account, it won't work because there will be a mismatch. And also when you change the payload, I mean when you change some kind of letters or characters in this string, it won't work because there will be some kind of error being thrown by JWT. But well, it's not so beautiful because, as you can see, there's always a way to decode it, because what is JSON Web Token? I mean, the second section of those 3 it's just a base64 string. So it's not an encryption, it's just a way of like writing down data. So it's more readable for machines, not for people. But as you can see, there won't be any password, of course, because that's like very, very uncareful, and it's better not to do that, and you shouldn't do that ever. And never put the password in your JWT. But what you can get from that is, for example, email, role, name, and sometimes user ID. So you don't have the password, but you have the email that you can use to brute force the password. And how to prevent from doing that? I mean, from stealing the data from JWT? Well, just use encryption. How to use encryption with JWT? Well, the second part of JWT is just a payload, which is like basically just a object. So you take this object, put it into some kind of like encryption algorithm. In this case, is AES 256, and you put this into the data key. So right now, there's no chance someone will decode it. It will take years, or someone would need to have the secret that's used for encryption. And right now, there's nothing really to steal because there's only this encoded thing. Sub is basically not really useful for the hacker. And IAT is basically created at, it's issued at. The next thing, the next vulnerability is XXE, and that's a bit less known, I would say. But what it is, it's XML External Entity, and that may be really harmful because if you have XML in your application, you probably know that this kind of XML objects is used like very often for like everything, every request to the backend. And suddenly in XML, there's something called entity. And this kind of entity where you have the declaration of it in the doc type, it's called XML External Entity. And when you use this kind of notation, what you're basically doing is you're creating an entity that's called XXE. That's basically doing the system command file etc password. So what it is effectively doing, it's injecting your users, your machine users, and sometimes passwords if they are really not secure, into the actual payload that any user may see. So this ampersand XXE in the product ID will become basically the content of the file. And you can use this with many other things, not only files. You can also spawn a reverse shell on that, and you can also like get some system files, configuration files, PHP files of the application. So you can get like, I don't know, SQL keys, so it's really dangerous. And how to prevent that attack? Well, there's only one option: disable external entities resolution and X-include in your XML parser. I think every parser on the market right now should have this option to disable it. And I really doubt that you are using this like intentionally. So just disable it, and this won't work anymore, and you'll be secure in terms of this kind of attack. Okay, so it was XML, so maybe let's jump to the PHP. PHP RCE is PHP Remote Code Execution, and it's, I would say, similar to the XML. But the main difference is that it's using PHP, and in PHP, sadly, there's a function called fsoc_open. And what this thing is doing, it's basically opening the HTTP socket on your machine. That's basically mainly used for transferring data in very old-fashioned way, usually with netcat. So on your if the attacker uses that method, he launches the netcat on his machine. Netcat is basically a tool that's listening on a port, and when it receives this socket, then it basically makes connection, and you can send commands to the machine, and you have basically a remote shell. So you're basically acting as a user on the machine. What you can do with it? Well, by default, it would have the privileges of the user that has the web server. So if you run the web server with sudo command, then you are basically screwed, because the attacker may do literally anything with your machine, steal your data, kill your server, use it for more exploitations, more vulnerabilities. So more people will get infected, or insert some malicious code into your application. How to prevent that and how it is usually done, because that's a PHP function. So you have to put it on the server in some way in order to be able to run it on the server and open the socket. And how to do it? Most applications nowadays have upload forms. I mean, most CMSs like WordPress or Django or Drupal. I mean, the first thing that you need to do if you have upload form is to restrict the PHP extensions, because when the server and the PHP interpreter doesn't see this extension, usually in the default configuration, it won't fire this function. Also, I think there might be a function in the configuration of PHP to disable that sockets, but that may also break some of other functionalities. So I'm not sure if that would be a good thing to do. This restriction in the upload form should be really enough. And when someone sees that this doesn't work, then he will give up. Also, when you have the upload form, also take care about the random file names on the server. So the file name isn't the same as the sent file name, and it isn't in the main uploads folder, because that's really easy to guess. And when it has a random name and random directory, it's almost impossible to guess the location of the file, even if it was sent. So the attacker cannot run this file to run this command. Okay, so we are getting deeper into more serious threats. SQL injection. Someone told that this kind of vulnerability doesn't exist this year because it's very old and almost everyone knows about it. But well, usually in the old days, the queries looked like this. So there was no escaping, there was just the variable injected. Now it's usually escaped, but the one thing that is usually not escaped nowadays is the grouping and sorting, because when someone takes effort and escapes this email and password and other things, then he thinks that the sorting and order is basically it's only a number, and so it's doesn't matter if it's escaped or not. And many applications nowadays have these parameters unescaped, so you can SQL inject using those parameters. And how does it look? Well, basically, as an email, you just specify a character that's escaping the SQL query. Usually it's a single or double quotation mark. And you type some kind of query, for example, or 1 = 1, which is basically true. And then usually you type two dashes, which means in SQL that it starts of the comment. So the query won't break in case there's something else after this param. And effectively, you have this kind of query. So as you can see, it will return basically the first user. Usually, if it's a get one, if it get many, it will get all users with all emails and all data. And by the way, it's also very crucial for this kind of attacks that the attacker has, the more information, the more you include into the select statement. So if you don't use some fields, or you use only one field, always specify that into this query after the select statement instead of this asterisk, because using this asterisk everywhere is really like dangerous, because you are sending, for example, I don't know, in this case, passwords in every request. So attacker might get that. Next thing, brute force attacks. This is exactly this. Is I would say a new thing, because it wasn't like there on the market like 10 years ago. And I would say it's doable on 60% or even 70% of the web pages. And I bet that web pages of at least some people in here have this vulnerability. So usually in the application, you've got a login request because you want to log in to the application. And I didn't log in because I got 403s. This GraphQL query is something else, don't look at that. I got this 403, so I got forbidden, so I cannot log in. My password or email is wrong. I don't know it because the message doesn't specify that. But there's one like interesting thing on this screenshot. For the lower times, we can assume that the email does not exist, and for the higher response times, we can assume that the email exists in the database. So this email is actually registered. Why? Because most of the authentication functions on backend look like this. So basically, the first thing we are doing is we are basically checking if the login or email exists in the database. And if it does, then we like get it from database and get the password from database, and then we compare the password from database with the hash of the user input. And the hash function sadly takes time. So for example, for bcrypt, it's like, it depends from the machine, but it's usually like 120 milliseconds for each hash. So the difference you can see in the like response times, that they differ. Like you can easily specify which logins were successful and which logins don't exist in the database. So it doesn't require very much knowledge. It doesn't require like tools. It's only a Chrome, and it's telling us the login or email of the user, and then we can use other kind of brute force attacks to get the password. And there's also, like, I would call it a standard way of doing brute force. It's backend-based login enumeration. Basically, it's used mainly on backends, because when you send a post request to backend, and even if you send all the times to hundreds, like or to ones, like to prevent hacker from seeing that it's a 401, it's like or 403, so it's forbidden. Even when you're doing that, usually your like response differs, because when the credentials are incorrect, you are sending the error with some kind of data. And when the credentials are correct, then you are sending the, I don't know, authentication token. And that's the difference in the binding, because By the way, byte length is the header that every response has to have because it's used by the HTTP interpreters. And it's basically changing depending on the kind of response you have. So you don't need to have check statuses if you have only 200s. You can just check the byte length, and then you know like if the credentials were correct. How to prevent hacker from doing that? Well, you can add some kind of changing field into the payload. So every payload is a bit different. For example, you can add varying length string into the response, but that will make a mess. So the easiest thing to do is basically to add some kind of, I don't know, maybe a timestamp, maybe some kind of information that will change over time that will mislead hacker from the correct requests. Okay, and what are the, by the way, that was the end of this section, and I don't see any questions, so I just continue. Potential hazards. So what may be the impact of any of these attacks? Well, the bad guy can have access to the server machine, and in fact, what it will do is it will provide access to the database, and therefore it will provide access to the user data. Therefore, it's a problem with the GDPR because it's a user data leak. So you have to report that to the European Union if you're in the European Union. So that's a big problem, I would say. Also, the machine can be killed or even broken, so it cannot be rerun. So, well, your page will go down and you'll need to fix it or maybe even restore it. And also, access to the server machine provides access to the internal network. So if your machine is in some kind of VPN that also contains other services that are not accessible from the internet, well, when someone is on the machine, then these resources are accessible for that guy, and with the simple network scan, he can get these IPs of these services and check what is this, and it sometimes may contain some confidential data. Well, it's biggest thing when the attack was on the Internet of Things Internet of Things device, because then the hacker may have access to the hardware part of that. So to the sensors, cameras, other recording devices. So it's a big privacy leak. Also, there will be ability to perform harmful operations that may result even in injury or death, because Internet of Things machines are not only intelligent, I don't know, toasters and fridges. It may also be intelligent, I don't know, heart starter. So it can be shut down remotely, and that, well, in fact, causes death. So that's really important thing to focus on the security when you're developing Internet of Things device, because that the consequences may be very, very huge. And that was quick section because I want to fit into the time. Okay, so how to prevent these attacks? I mean, that sounds scary. Even if our application doesn't do much, it may be hosted on the corporate network in the internal VPN. So when the attacker goes into that. Well, our application is just hello world, but it's also an ability to get into the machine and check what's there. So every application should be secured, no matter how complicated, even the simplest ones. That's my opinion. And how to prevent. You can always schedule security audits and pen testing sessions for your application. If you're working in some kind of corporation, that's probably always required for the official applications. And you always have to think about the possible security issues during the planning of a project, because usually when we are doing planning, we are mainly focusing on the KPIs, on the goals, on the business values, on the things that the client wants, because the client is usually in this planning. But there's also a need to think about the security, because that may be really it may even destroy your project in the future if there will be a big leak. And you also need to extend your knowledge about the security by reading about new threats and participating in webinars. For example, you can read some kind of, I don't know, online portals about the security. You can check the new vulnerabilities. You can follow your technologies patch notes. Like if there's a new version of that, you probably need to update. Also, there are many conferences about the security in the Europe and all over the world that you can participate in. And there are many and many guides and tutorials in the internet on how to prevent attacks and how to be secure. And these 3 rules are basically, well, that should be enough, to be honest, to prevent 99% of the attacks, because, well, the point of prevention from the attack is not to make the hacker unable to perform the attack, because the attack, to be honest, may always be performed. There's no machine in the world that cannot be hacked. These are words of someone really important that I forgot the name of. But yeah, even, I don't know, NASA machines, the NSA machines, FBI, every of these corporations had a leak before, because there's no machine that's secure in the world. So the point is not to make this not doable, but to make it so hard that the hacker will resign and decide not to do it, because it's a waste of time and it would take too much. So it's not about security of application. It's not about being fully secure, but it is about being more than less secure, and that will always help. And we're going to the post-mortem section. Post-mortem is basically, it means in the Latin after death, because it's a process that's being conducted when, well, there was an attack on your machine, there was a leak on your project, and you need to investigate what happened, why happened, who did that, who did what, when, basically. And how to do a good post-mortem. The first thing is that the post-mortem isn't optional. It shouldn't be optional. It should be performed after every leak, because it's crucial to know what we need to fix, what was the weak point. So the first rule I would say about creating post-mortems is the whole team should be present on that meeting, because no matter if that's a PM, if that's a DevOps, if that's a developer, everyone should know that there was an accident, and everyone should know why this happened, and everyone should know what should we do to prevent from that kind of incidents in the future. The next thing right now, as I mean for the European Union's projects, is to check for the GDPR data leak, because there are some requirements that this has to be reported like almost right away. So if you don't do that, then there may be a big fee for a company. So it's better to do that like sooner than later. And the rules of, I mean, the like conditions on to GDPR, I mean, to clarify what was the GDPR leak, what wasn't, are available on the European Union like sites. But I think in your company, if you are working in like some kind of company, and there's usually a guy who's like delegated to do this GDPR work, or maybe even just a lawyer that will care about that, because that's really complicated and developers probably shouldn't do that. But the only thing the developers should check if there was any leak of personal information from the database or the application, or if the user could see other users' data, because if that happened, then it's probably GDPR data leak, and the rest of the process will be like handled by the law department usually. Next thing is to check for data loss, because, well, there was an accident, your application logs are telling you that someone was on your machine, but then like he resigned and exited. But in fact, even if one of your users was deleted from database, or even if one of your, I don't know, comments was deleted from database or changed in any way, well, that's also may be considered a GDPR data leak, because, well, what it's giving us, it's giving us the information that the hacker was in the database, so he saw the data. And you should always check the database and database logs if you have access to it for any kind of modification or removal. Identify what was the weak point, because every attack has its like target. It's usually like preceded by the enumeration, which basically gives us the list of the weak points of the application. And if there was an attack, then you need to identify which technique the hacker used to perform it. And even if you identify that, then you also need to ask someone, external company or your company, for a pen test and security audit. Because the fact that you found this issue doesn't mean that there are no other like vulnerabilities in your application. That actually may tell you that well, the security wasn't as important before because there was some kind of vulnerability. So there may be other ones. So it has to be checked by the people who know how to do it. And the next thing is to create an action log. And that's, I would say, crucial. And it's just basically who did what when. So it's basically a kind of a timeline on which you just put marks that in this point of time the attack started. In the other point of time we discovered it, and you also need to like annotate how much time the attacker could be on the machine, because that's also very important, because it gives you the scale on how much he could do. Also, it's very like, I would say, important to mark who was doing what when this attack happened. I mean, when was the fix created? Who did that? And the actual, I don't know, link to the Jira pull request that it was done. And after, on the end of this action log, there should be an event, a point in time that's basically called mitigation. That's it's telling you that the fix is on the production. There was a security audit connected, and it's like, as a result, you know that your application is no longer vulnerable to that. And the last thing of the post-mortem is the cure. So it's mainly about the how the vulnerability was fixed, and how do we know it's fixed? I mean, if there was some kind of, I don't know, let's say XXE, then we need to like explain that the XXE can be mitigated by adding these rules to the parser. And we know that, and we are sure about that because we tested it locally, and then on the staging, and then on the testing environment, and then on the production, and every test like resulted in the failure. So it was not possible to perform that attack anymore. And the cure is basically the proof that your application is no longer vulnerable to that kind of attack right now, because in the future, I don't know, the XML parser may change, so it will like be vulnerable in the future. But for now, your application should be secured from the kind of attack if you have had this accident and fix that issue. Okay, so how to start like in the web application security? There's something called CVE, which is basically a big log or register of the vulnerabilities that's available in the web as the web page. And what you can do is you can go to the CVE. Its link is in the QR code below. And you can type in any technology that you are using and the version of it. For example, I don't know, Python 3.6.12, and check if there's any kind of vulnerability like found. Also, if your machine is using, I don't know, SSH, then you check if OpenSSH version 10.2 is vulnerable. Also, you will be able to see what kind of vulnerabilities there will be. It may be remote code execution, remote shell, data leak, denial of service. So it's always on the page. There's also a thing called sneak. If you are using GitHub, it's automatically scanning your project and the packages you are using. And it's telling you that some part of code or some packages in your code are now vulnerable, and you need to fix that by updating probably, or by applying fix manually, because there's no update yet. And it's really a good thing. It's free to use. I think for corporate users it's not, but for yourself you can use it for free. And the most important thing is be up to date, because when you're using a WordPress version from 2009, it's almost certain that there will be a vulnerability, and the attacker may very easily like go into your application and do whatever he wants. Well, looks like I actually finished a bit before the time. So that's a good thing, because we didn't skip anything, I think. And I don't see any questions in the QA section. Yep. So that will be basically it, I think.
So if you don't have any questions, then thank you, Michał, for sharing your knowledge with us. And thank you everyone for the participation. We hope you've had a great time and enjoyed the webinar. If you're interested in our upcoming events, follow us on Facebook and find more on meetup.com. So thank you very much. Have a great evening.
Thank you and goodbye.